Python Full Course Part 3. For thousands of years, humanity has been obsessed with one thing: organizing information. We've used clay tablets, papyrus scrolls, and filing cabinets the size of buildings, all in a desperate attempt to bring order to chaos. But what if I told you that the entire history of data, from the Library of Alexandria to the engine that powers Google, could be understood using just a handful of simple digital containers? These aren't physical boxes, they're ideas, and the language that builds them is Python. Today, we're not just learning to code, we're learning the secret language of organization. This is the story of Python's fundamental data types. The bridge from story to workshop. It sounds like a huge topic, and honestly, it is. But here's the secret. You already understand it. You use these concepts every single day without even realizing it. When you make a to-do list, when you look up a friend's number in your phone, when you decide if your coffee is too hot or just right, you're thinking like a programmer. All Python does is give you a specific, powerful vocabulary to talk to a computer about these ideas. So, in this video, we're going to bridge that gap. We're going to take the simple ideas you already know and translate them into the language of Python. This is the single most important step in your journey. Once you master this vocabulary, you're no longer just a user of technology. You're on your way to becoming its architect. Fire up your code editor. Let's begin the translation. The foundation, strings, the digital word. Let's start with the most basic unit of human information, the word. In Python, we don't just call this text, we call it a string. Think of it like a string of characters all tied together in a specific order. Anything you can type, from a single letter to the entire text of Moby Dick, can be a string. To create one, all you have to do is wrap your text in quotes. It can be single quotes or double quotes. Python doesn't care as long as you're consistent. My underscore name equals Alice. My underscore book equals Moby Dick. Now, why is this important? Because once the computer knows something is a string, it gains superpowers. You can ask it questions. For example, you can ask for its length using the len function. Len my underscore name, and it tells us 5. You can even tell it to change its case underscore name upper, and suddenly it's screaming Alice. These built-in abilities are called methods, and they are like a set of tools that come pre-packaged with every string you create. It's the fundamental building block for any program that needs to work with text. From a simple search engine to a complex AI chatbot. Next up, numbers. In the real world, a number is just a number, but to a computer, it's a little more specific. Python primarily sees 2 types. First, you have the integer. This is your classic whole number. 1, 10, -500. No decimals, no fractions. Just clean whole numbers. My underscore age equals 30 items underscore in underscore cart equals 5. But what happens when you buy something that costs $19.99? That's where the second type comes in, the floating point number, or just float for short. A float is any number with a decimal point. Price underscore of underscore coffee equals, for 0.75, pi underscore approx equals 3.1 for 159. And why the distinction? Why does Python care? Because it handles them differently behind the scenes. Integers are precise and simple. Floats are more complex and are used for calculations, where precision after the decimal point matters. The key takeaway is this: if you give Python 5 plus 2, it knows it's doing integer math and gives you 7. If you give it 5.0 plus the 0.0, it knows it's doing float math and gives you 7.0. It's a subtle but crucial difference that prevents bugs in complex calculations, especially in the world of finance and scientific computing. Lists, the ultimate to-do list, okay? Strings and numbers are great, but they're lonely. They only hold one piece of information at a time. What if you need to hold a whole collection of things? Imagine you're going to the grocery store. You need a list. In Python, we have the exact same thing, and it's brilliantly called a list. A list is an ordered container defined by square brackets that can hold anything you want, with each item separated by a comma. Grocery underscore list equals apples, milk, bread, coffee. This is where the magic starts. Notice that word I used, ordered. This is a huge deal. It means every item has a specific position or index. And here's a pattern interrupt, a critical rule you need to remember. Forever, programmers don't start counting at 1. We start at 0. So, in our list, apples is at index 0, milk is at index 1, and so on. This means we can grab any specific item we want. Grocery underscore list 0 gives us apples. Grocery underscore list 2 gives us bread. We can even change items. Let's say we want to swap bread for pasta. No problem. Grocery underscore list 2 equals pasta. Now our list is updated. Print grocery underscore list. This ability to change is so important it has its own name. A list is mutable. You can mutate it or change it after you've created it. Think about it. What are some mutable lists you use every day? Your Netflix queue, your Spotify playlist, the contacts in your phone. They are all just complex versions of this simple Python list. What are some other examples you can think of? Let me know in the comments below. I'd love to see what you come up with. Tuples, the list that can't be changed. Now, if a list is mutable, what if you need a list of things that you absolutely, positively cannot allow to change? Imagine you're storing the GPS coordinates for the White House. You don't want some other part of your program accidentally changing that address. For this, Python gives us a tuple. A tuple looks almost exactly like a list. Instead of square brackets, it uses parentheses. White underscore house underscore coords equals 38.8977 minus 77.0365. Here's the key difference. Let's try to change the first value. White underscore house underscore coords 0 equals 40.0. And we get an error. Python literally stops us. It tells us a tuple object does not support item assignment. This property of being unchangeable is called immutable. You might be thinking, why would I ever want a list that I can't change? It's a fantastic question. Answer is safety and predictability. When you use a tuple, you are sending a clear signal to anyone reading your code, including your future self, that this data is a constant. It's a rule. It's not meant to be altered. This is vital for things like coordinates, RGB color values, or configuration settings that must remain fixed for your program to work correctly. Dictionaries, the ultimate filing cabinet. Okay, one final container, and it's the most powerful one yet. Lists and tuples are great, but they have a weakness. To get an item, you need to know its index number. You have to remember that milk was the second item at index 1. What if you could just ask for milk directly? What if you could label your data? For that, we need a dictionary. A dictionary is the master of organization. It doesn't use numbered indexes. It uses custom labels called keys. A dictionary is a collection of key value pairs wrapped in curly braces. My underscore contact equals name, Alice, phone, 5551 to 3 for email, alice@email.com. Look at that. It's clean, it's organized, it's human readable. Now, if I want the phone number, I don't need to remember if it's at index 0, 1, or 2. I just ask for it by its key, my underscore contact phone. And boom, I get 5551 to 3 for Dictionaries are also mutable. I can add a new key value pair easily. My underscore contact city equals New York. This key value system is one of the most important concepts in all of programming. It's how your phone stores contacts. It's how websites store your user profile. It's how AI models store complex settings and parameters. It is the digital filing cabinet that powers the modern world. Let's take a breath and recap. We have strings for text. We have integers and floats for numbers. And we have 3 ways to store collections: the changeable list, the unchangeable tuple, and the labeled dictionary. These 5 concepts are the foundational pillars of Python. Every complex program, every AI model, every video game at its core, it is just manipulating these simple data types in incredibly creative ways. You've just learned the alphabet of a new language. You now have the building blocks. What good are building blocks if you can't do anything with them? You have the data, but how do you make it work for you? How do you write a program that can actually perform a task, that can solve a problem, that can make a decision? Now that you know the nouns of Python, it's time to learn the verbs. Let's talk about the secrets of functions, engines that turn data into action. By watching this next video,